So guys, maybe I'm not understanding something, but this video I want to show the difference between using a MOSFET and an RF circuit and using a bipolar junction transistor. So kind of an interesting observation I'm making here. So this is a very basic RF circuit. So we have our choke, output decoupling capacitor, our stabilization capacitor, and our output network here, going to 50 ohm load. We're driving this with a MOSFET driver, cosine 4420, running off of an 8 or 7 volt power supply. And this is a 2SC520N, a bipolar junction transistor from Toshiba. So I'm doing this experiment in real life. In real life I do have a MOSFET there, and trying to figure out why it keeps popping. So, but on this simulation here, it looks fine, and actually the average power dissipated in the transistor is only 10 watts. But if we increase the drive level to like make this resistor 3 ohms, what's interesting is we're actually now dissipating more power in the transistor. So kind of interesting situation here. I think this has to do with the stabilization capacitor, because this is kind of a Class E design here, a Class E output network. But I think the rise and fall time, the drive level, and this capacitor here for the Class E amplifier, they're kind of intertwined with each other. So yeah, you don't want to overdrive the amplifier. You don't want to switch it too fast, actually, because that would cause problems, like I will show you soon here. So yeah, so now we can close this and open this circuit. This is we're actually using a different one here. We are currently using this one in real life. So yeah, this is cosine 420 and 3 ohm load. Actually it's a 6 ohm, no, it's a 3 ohm load. Okay, so we're gonna run this and see what happens. So first of all, you can see these little spikes here. These are actually very, very big, and they couple up back into the gate, causing the MOSFET driver to fail. So they look small here, but they're actually very high voltage. Other than that, this is all fine. But these are like the worst thing. They're really annoying to deal with. And I've blown so many MOSFET drivers. But again, maybe I'm doing something wrong. Maybe I don't know. But I'm gonna still build the same circuit with the BJT in real life and see what happens. So anyways, we can take a look at the power. It's actually 35 watts. And yeah, this is correct, because with the 50 volt power supply, this is pretty much what I'm getting, is 35 watts of power being dissipated in this transistor. So kind of an interesting, yeah, I don't know, maybe it's, again, maybe you have to switch it slower, because switching this in a few nanoseconds causes a huge mess. Or maybe I'm just doing something wrong with this output network. But anyways, see you soon, I guess.